Everybody. Hope everybody had a good weekend. We are going to go over the review sheet today. That's going to be our assignment today, plus to look over any material for the test that we're going to take tomorrow. Just remember that any test you take right now will only help you. It cannot hurt you with your grades. So my advice to you is just do the best you can. And you're going to have a time limit on the test. It's 1.5 hours for 28 questions, so that should be plenty of time. And like I said, just do the best you can, and consider it really a gift because it's kind of an open book test. So here we go. Let's go over the review sheet. This should really help you out for the test. So you have your classic group questions here, 1 through 3. They give you a picture, the sun, the earth going around the sun, and of course what goes around the earth is the moon. They give you 4 different positions of the moon: M1, M2, M3, and M4. So question 1 asks you, an observer at location A on Earth views the moon when it is at position M3. So you have the sun here, you have the Earth here, and here's the moon. And remember, we can't see from Earth the outer part of the moon. So at M3, I'm just going to cover the part we can't see. And to us, it looks like over here, nothing is shaded. That would be a full moon. And that is C. Okay, number 2. At which moon position could a solar eclipse be seen from Earth? So in order to get a solar eclipse, remember we name our eclipses for what's getting blocked when we're standing on Earth, what happens, what's starting to shade in. A solar eclipse would mean the sun is starting to get blocked. So here's the sun, here's the Earth, and the only way to get a solar eclipse is for the moon to actually block the sun. So it's got to be position M1. So for number 2, should have gotten A. Number 3. An observer at location A noticed that the apparent size of the moon varied slightly from month to month when the moon was at position M4 in its orbit. What statement best explains this variation in the apparent size of the moon? Really, just kind of take a look at the answers here, and or the choices. And what you should know is, remember we talked about apogee and perigee. Apogee is when the moon is furthest away from Earth, and perigee is when it's closest. And the moon would appear to be larger if it's closer to us. So what affects the apparent size of the moon when we're looking at it would be the moon's distance from Earth. And it actually changes in a cyclic manner. Cyclic means predictable. Okay, it's going to be a long video. Next is number 4. This is a question that I noticed a lot of people were mixing up. And, if we were in class, I would totally tell you what to do. But since we're on video, I'll tell you via the video. The actual shape of Earth's orbit around the sun is best described as, this was on one of your worksheets, and I noticed people were answering C. That is a classic answer here. The oblate sphere is actually the shape of Earth. They're asking you the shape of Earth's orbit around the sun. And a nice way to remember this is, I'm going to go to page 15 of the reference table. And remember eccentricity. The closer you are to 0, 0 looks like a circle. So I'm going to go to Earth and 0.017. That is very close to 0.000. That tells us that we have a slightly eccentric ellipse. You just got to know that. Alright, but that's just a way to kind of jar your memory if you go to page 15 of the reference table. So that takes care of 1 through 4. Let's go to number 5. 5 through 8 is based on this calendar. So number 5, well, let's read, remember what I told you with group questions, always read the instructions. Base your answer to questions 5 through 8 on the calendar below, which shows the month of July of a recent year, the dates of major moon phases as seen in New York State are shown. So you can see here, if you look right here, we have a new moon. The key is on the right-hand side. That's your new moon. A week later, we have the first quarter, and remember what we say, the moon will light on the right. Then, about 8 days later, we're at a full moon, and now it's shading in. Now we're at the last quarter, and then we're back at a new moon. And look how long it took. 1 month. Alright, so the diagram below represents the phase of the moon observed from New York State one night during the month of July. When I take a look at this picture, notice it looks like it's shading in on the right. That tells me that we must have just hit the full moon, and if you follow the pattern here, you could kind of see that you're going from fully shaded, it's lighting on the right, it's fully lit, and then it shades in on the right, half. So if we're shaded in a tiny bit on the right, we have to be somewhere between the 16th and the 23rd. And the only answer that is in between July 16th and July 23rd is C. Alright, on which date will the next first quarter moon phase occur? So I'm going to look for the first quarter moon phase here, and that's what a first quarter moon looks like. That would be July 8th. And we said basically every 29 and a half days, 29 and a half days, we get the repeat of whatever phase we were looking at. So 29 days after the 8th would put us, this is 31 days in this month, that would actually put us at August 6th. And there's your answer, August 6th. Eclipses do not occur every month. This is another question I saw that people were getting a little bit mixed up on. Eclipses do not occur every month because the moons, every month, the sun, the earth, and the moon are kind of aligned, but the thing is they're not lying perfectly flat, like say on the surface of this pencil. One of the orbits, usually the moon's orbit, is a little bit above where the sun and the earth would be, so we would say the orbit is inclined. Okay, so for number 7, we don't get eclipses every month because the moon's orbit is inclined a bit. And why does the moon's gravity have a greater effect on our tides than the sun's gravity? And I mean, think about it, the sun is much larger than the moon, but the reason why the moon has so much more pull on Earth is because it's really close to us. So 8 would be D. The fact the moon is much closer to Earth, there's a lot more gravitational pull. That takes us 1 through 8. Now I'm going to go over numbers 9 to 16. We're already at 8 minutes on this video. We're not really cruising. Okay, number 9. They didn't give you the arrows, but remember what I told you to do. You could kind of just complete the circle. So you go like that, like that, like that. Oh, this is terrible. Like that, kind of like that. I'm doing this very fast. And like that. The most important one here is position 8. And we want to know which image correctly represents the moon at position 8, how we see it from Earth. So remember what I told you to do. Just kind of draw an arrow, and you want to be looking from Earth. So this is pointing at me, right? So I got to turn this around like that. Now I'm looking from Earth. I'm going to cover the outer part of the circle because this is the outer part is where I can't see that side of the moon. And now if you take a look, it looks like it's lit up a little bit on the left. That would be a crescent moon on the left-hand side. And the choices, looks like D is your choice for number 9. A little bit lit up on the left-hand side. In our solar system, this is another question I noticed a lot of people were getting mixed up. The orbits of the planets are best described as, if you remember Kepler's first law, which is on the test, you'll see that detailed list of what you should know for the test in my post today, but this is definitely one of them, Kepler's first law. In our solar system, the orbits of the planets are best described as, well, remember we said they're not perfectly circular, so it's not that. They are elliptical. And think about it, a focus is something that does not move in the center of our ellipse. So, or not in the center of our ellipse, but somewhere within the ellipse. So, think about our solar system and what does not move in our solar system. This is one of the foci for every single planet in our solar system. So D for number 10. All right, let's go to number 11. The diagram below shows a model of the moon's orbit around Earth. Letters A, B, C, and D represent 4 position in the moon's orbit. What is the approximate length of time the moon takes to go from position A to position C? So if this is the beginning of the month, think about it. It takes a full month to go all the way around, and a full month is right about 30 days. So A to C is only halfway for the cycle of phases. The cycle of phases is 30 days, and we're only going half of those 30 days. The correct answer has to be B. Okay, so that's number 11. Number 12. This is another question I like. Now, they didn't shade it in for you here, but the diagram below shows Earth is viewed from above the North Pole. Points A and B are locations on Earth's surface. You know what I'm going to do? Here's the sun on the left-hand side. I threw this question in because you never really see the sun on the left-hand side, do you? All right, this is the North Pole. So this is like looking at a picture from above. So I'm just going to shade in the side that's facing away from the sun. That would be nighttime, right? And then what they're doing for you is the arrows are showing how we're rotating, right? So look at position B here. Isn't it about to rotate into the sun's rays? It's going from nighttime into daytime. So this would be sunrise, which is right around 6 a.m. And right here, it's rotating into nighttime. That would be sunset, which would be 6 p.m. So here's 6 a.m., here's 6 p.m. We're going like this. This would be smack in the middle. I believe that would be in the afternoon or around noon. So the best answer for number 12 is, I'm sorry, it said at location A the time is 12 noon. I read that wrong. My bad. Alright, so this is noon. Over here. Oh no, I'm right. 6 a.m., noon. They wanted to know location B. That's what I got wrong, location B. So, sunrise is 6 a.m. I already told you that. Choice A. Alright, let's go. We're getting close to the end. Number 13, which diagram sequence correctly shows the order of moon phases as viewed from Earth for a period of month? We always start with the new moon. So, if you take a look, choice A starts with a full moon, choice D starts with a full moon. That's not good. Now we're left with these two. And remember, the moon will light on the right. So, you could see this is just off. This is off. We don't go from a new moon to a full moon. We go from a new moon, lights on the right, full moon, and then it shades in on the right until we are back here 30 days later. So the correct answer here is B. Number 14, diagram 1 shows the moon in its orbit at 4 positions labeled A, B, C, and D. Diagram 2 shows a phase of the moon as viewed from New York State. At which labeled moon position would the phase of the moon shown in diagram 2 be observed from New York State? Again, remember what I told you to do? Continue the circle, continue it through the moons that they give you. And I'm going to look, I'll just go choice by choice and see which one. It looks like it's mostly lit up on the right. So, if I look at position A, I'm going to, this is good, right? Because here's Earth, and our arrow's pointing at the moon. I don't need to turn the page here. And it looks like it's lit up a little bit on the right. So A is not the answer because it's our diagram. It's mostly lit up on the right. So I'm going to eliminate A. Now I'm going to go to position B, make sure I'm looking from Earth, and I'm going to cover the half that we don't see. And look, it's shaded in just a tiny bit on the left, mostly lit up on the right. Shaded in a tiny bit on the left, mostly lit up on the right. Choice B is our answer. Okay, now let's go to, just gotta keep my stuff going here, last page. This is a good question, number 15. I like the bar graph. They want to know which characteristic is being, well, the bar graph below shows one planetary characteristic identified as X plotted for the planets of our solar system. I'm doing a terrible job today on this. And here you go, Mercury, little over 0.2. Venus is just about 0.00, Earth is a little over 0.00, and Mars is just under 0.1. You know what? When they're talking about planetary characteristics, I'm going to go here. And I believe I said Mercury was just over 0.20. Venus and Earth were very close to 0.00, and Mars was just under 0.1. Looks like we're talking about eccentricity of orbit. Eccentricity of orbit, which is choice C. Good. And then lastly, number 16, another question I noticed people were flip-flopping on the question sheet I had given earlier. Which diagram shows a planet with the least eccentric orbit? So remember, eccentricity is always between 0 and 1. 0 looks like a circle. So the closer you are to 0, that means it's less eccentric, the least eccentricity. Closer to 0, it should look more like a circle. Therefore, the one that looks most like a circle here is A. The most eccentric, if they were to ask that, would have been the one that's furthest from a perfect circle. That would have been D. But in this case, least eccentricity, that's your choice. All right, hopefully you're not too bored with my 17-minute video. Guys, look over your stuff briefly, and again, use it to your advantage tomorrow. Let's get a good grade, 28 questions, and that's it. Have a good day, and we'll see each other hopefully soon.